Hello guys and welcome back. Let's keep on going with our setup. Next thing I want to do is to create the tail. But if you really think about it, for the tail and the wall, there is not really that much of a difference other than the mesh is, different. So we'll have to just maybe create a base class for that. I think that would be something we can do. So yeah, I'm gonna go ahead and create a new class based on overlappable, and it's gonna be called DeadZone. Right, this is gonna be the DeadZone for overlappable, right? Create class. Now we're trying to make things flexible. There are a lot of things we can go for like a shortcut, to make things kind of like easier at the moment, but it's going to be harder in the future. So we are creating something we have the extensibility in mind. So that zone can be something else, right? Well, no matter what overlaps with the that zone will cause game over. That's what that zone does, and there's nothing more than that. Okay, so here I'm gonna go to the fruit and I'm gonna go steal that, copy that and go to that zone and paste that in here. Of course, it has to be public. Okay, maybe we can make it private or at least protected. Let's not worry about too much of those details. I'm gonna, of course, re-implement that in the DeadZone. So void a DeadZone column and then the function, right? Now here we're gonna call something we call game over. And again, that's something that's particularly important, right? It's kind of like the rule of the game. So I'm gonna do that in the game mode. Okay, let me go to the game mode. I'm gonna create another function called void game over. Okay, and then I'm going to implement that. Copy that and go to the CPP file. I'm going to then say void AC greedy snake model game over. And here, let me just pause the game for now. Right, so gameplay statics set game paused. Okay. And then again, we need to specify which world are we using. So this should be fun. And then paused to true or false. We're gonna say yes, true, right? This will pause the game for now. Okay. And then we can also ue log temp warning and then text game over. Game over, right? Cool. Now in the DeadZone, right, we can just say game over, but we need to ask the game mode to do that. So we can say get world. Get world is available for all actors. It's a very convenient thing. The world is the top thing of your entire map. So the world is, this thing, the entire map you're playing. Now all the actor can get that, and then get author game mode. Okay, that's the game mode, right? But we need to convert that into our game mode. So I need to include the header of the game mode. So include C greedy snake game mode base, right? And then I'm also gonna create a variable for that. So AC game mode base, right, pointer. Game mode will be equals to cast C game AC game mode snake game mode base. We're going to cast it, get also game mode, right? So basically we're getting the game mode from the world. We cast it again, the same casting mechanic we were talking about in the overlappable here, right? Casting that so that it becomes the type of our game mode. Now just in case that does exist, we can say if game mode, and then we can get game mode do something, right? Then in this case, game over. Okay, that way we're making the game mode to handle those things. Now this is important. If we want to change something else, change how the game over behaves, we can just change this one instance of the game over function in the game mode. So whoever is calling game over will carry that, will call the function, so they will all do the same thing, right? That way the code is easier to manage. Okay. All right, so game mode game over is in here. Now whoever overlaps with our DeadZone will basically game over, right? Do that, compile this, let me clear the log. Of course, the DeadZone will also be kind of like a lower level concept. We don't give it any model yet. So I guess the next thing to do is just right click and create another child blueprint class, and I can call this guy tail now, right? Create class. Okay, the tail class will have nothing more. I don't think we even need to give it anything, because I want the tail to be just the same as, using the same model as the snake head. But I want it to be smaller, so I probably can set it the size here in the begin play for the tail or constructor. So let's do that. For the tail, I want to just change one thing. Okay, so I'm gonna say I can do a lot of automatic things in here actually. So let me create a tail here, right, for the constructor, and also begin play, and override the begin play. Right, that's the two things I want to be different. Here I'm gonna say a tail here. I want the size of the tail to be smaller, so we can say mesh set relative scale 3D to be f vector 0.6. So that's gonna make it only 60% of the size of the head. That way it's easier to see which one is the head, and it can avoid initial overlapping in this case, right? And that's probably the only thing I want to set up for the tail, just to make it smaller. However, in the begin play, I also wanted to make the mesh to use the same mesh as the snake head, right? So I'm gonna do begin play also. Void a tail column begin play, right? First of all, you almost always want to call super begin play, which is calling the begin play of the upper class, right? And then you do whatever you want to do after the upper class is set up. So I'm gonna say I'm gonna include snake head. Okay, I'm gonna say a snake head pointer owner equals to get owner. Okay, and we have to cast it. Again, just to be sure we're not casting something that's not a snake head, let's check if owner, right? And then we can say owner mesh. We're gonna set our mesh to be the mesh of the owner basically. So we can say mesh set static mesh. We'll be getting the owner dot head mesh, right? Dot get static mesh. I'm saying dot, but I'm actually needing to type in an arrow. But dot, when you type in dot for a pointer, my Visual Assist will change that for me. So if yours is not changing, When you hear dot, I probably will be saying an arrow in this case. Okay. So basically when the game begins to play, right, we're getting the owner, which should be the snake head if we define it when we're spawning it. Right? If owner exists, we just set our mesh to be the mesh of the owner. Right? That's what the snake head does in here. Of course, it's also 60% of the size. Okay, let's go compile that. While it's doing that, we can also go back here to the snake head. Now after eat fruit, oh, got an arrow. Let's take a look at that. Declaration of owner has class member. Oh yeah, this is actually also one of the variables. Had owner maybe. Snake head owner. Right, because there's actually a variable on the parent class that's called owner. Right, we probably don't want to change that. Okay, let's go back and compile this. All right, now it's successful. So let's go to the snake head. So when we eat fruit, of course, we're printing out score. Let's also spawn a tail, right? That means I need to know what tail is by doing a hash include tail.h, right? So here we can say f vector spawn tail spawn location will be equals to get do head mesh dot get world location, get component location. That should work. That where the head mesh is, right? Get that component's location, and then we minus the move direction times move step size. So that way we're basically finding a location that's one step behind the head, based on, of course, the move direction. Now with that being set it up, we can also do, I don't think the rotation matters, so let's not worry about that. And I'm gonna say a tail pointer new tail will be equals to get world, just like how we spawn the camera. We can use get world, right, and then spawn actor, right, and the spawning actor will be again a tail, and then we can also say a tail column static class, just to be more specific. Spawn location will be the tail spawn location, and spawn rotation will be f rotator nothing, so we're not really care about that. Spawn parameters again will be a default one here. That's going to give us a tail, right? Now before we, oh, actually I kind of wanted to change the spawn parameters. Let me create one. Oops, sorry about that. Spawn parameters will be equals to nothing yet. And then we can set up a few things. Spawn parameters dot owner, right, will be equals to this, right? So that way we're setting the owner. I don't have to have the parentheses. Yeah, let's get rid of that to make it a variable. Okay. Right, so this way, we're defining the owner here to be this. So when the tail is beginning to call the begin play, it already have an owner here, right? That's why we need to set up the owner here, right? So when it's spawning, it's already having an owner, right? We can also just be a little bit more specific. We can see we can say spawn parameters dot be a collision or collision spawn collision handling override will be equals to the spawn collision handling methods, and then always spawn. That way we can guarantee that they will all be always spawned. There could be situations like it detects a collision, so you can avoid spawning. But in this case, we kind of wanted to avoid that. Okay, now this will spawn a tail, right? So I'm gonna go ahead and compile this. And then let's try it. I'm gonna go play. Right, you can see we have a little tail spawned right behind the head. Now because it's a dead zone, when I hit this tail, you can see now I have game over printed on the bottom. So everything's working except the tails. Right? Those new tails are not following me. Okay, so that would be cool. So let's go ahead and do in the next video, right? Let's set up the tail so that they're following the head when they're spawned. Okay, see you next time.